Okay, welcome back once again to all my dear students. Today we are going to discuss about the polarity of bond polarity. But before starting that, let us revise the topic which we had discussed yesterday, that is the VSEPR principle. There is a valence shell electron pair repulsion. Here we can say that the Lewis approach is not being able to explain completely about the structure of the molecules, right? So here who will explain it? The structure of the geometrical shape of the molecule, that is the Nano and Gillespie. He has presented, developed it, and in that VSEPR principle, that is a valence shell electron pair repulsion. What he says that the geometrical shape of the molecules is depend upon the bonding and the non-bonding electron pair around the central atom. Means the number of bonding and non-bonding electron pair. Second thing, he says that here in the outermost orbit or valence orbit, there is a electron which carries a partial negative charge, and there is a repulsion is there. Then third point, he says that the arrangement of the electron will take place in the space in such a way that it attains the maximum distance and minimum repulsion, right? Fourth point, he says that if more than one resonance structure is possible, then VSEPR principle is applicable to any of the resonance structure. And last point, that with the help of VSEPR principle, it is helpful to find out the geometrical shape. Most probably we can say that P block element, right? And we have also discussed certain examples, just like SO2, then methane, CH-4. Then we have also discussed about the water, H2O, ammonia, NH3. What is the bond angle? And according to the VSEPR principle, he says that the maximum repulsion is there between the non-bonding electron pair. That is a lone pair. Then comes bonding pair and lone pair, and then comes bonding pair. Understand? Right? So all these things you have to know very well. Okay. Now today, next topic, that is the polarity of bond. Let us start about polarity of bond. Bond polarity, that is, right? Now what do you mean by bond polarity? Any chemical bond does not possess completely ionic or nor completely covalent, right? There is some, if ionic bond is there, then there is some covalent character is there, and if covalent bond is there, then there is some ionic. It is not completely ionic and not completely covalent, right? So let us write out the first point. That is, first one, any chemical bond does not possess what? Completely ionic or completely covalent nature. Completely ionic or completely covalent in nature. If I take the example, just like in molecules like H2, O2, Cl2, N2, right? The covalent bond is formed by sharing of electron. The covalent bond is formed by sharing of electron. By sharing of electron, here we can also say between two atoms. Right? But we can say that experimentally, but when the experimental value of bond length and bond enthalpy are studied, but when experimental value of bond length and bond enthalpy were studied, what is this? That we found that there is some contribution of ionic bond. it is found that there is some contribution, of ionic bond. There is some ionic bond, ionic character will be present. Just like if we take the example, heteronuclear diatomic molecules, like hydrogen fluoride, HF, right? Hydrogen fluoride. The electron pair of covalent bond remain direct more towards the electron pair of covalent bond drag more towards fluorine atom. Why? Because more towards fluorine element. Why? Because we can say that fluorine is more electronegative than hydrogen atom, because the electronegativity of fluorine is more than hydrogen, right? So fluorine carries a partial negative charge and hydrogen carries partial positive charge. Thus the fluorine carries partial negative charge, that is minus delta, and hydrogen carries partial positive charge, that is plus delta, and thus whatever the bond is there, it becomes polar. Understand? So here I can write down H-F, and this can be written as hydrogen and fluorine non-bonding, and here partial negative charge and here partial positive. So whatever the bond is there, it becomes a polar, right? So dipole moment is found in the molecules due to this property of polarity. Thus the dipole moment is found in the molecules due to this property of polarity. Polarity. Understand? Because as there is a difference in the electronegativity. Is it clear? In the same way, if I take the water molecules, then what is that? One oxygen atom in water molecules, what is that? One oxygen atom is joined with and two hydrogen atom combine to form two covalent bonds. One oxygen atom and two hydrogen atom, right, combine to form what? Two covalent bond. Okay. Now here also we can say that the electronegativity of oxygen is more as compared to that of hydrogen atom. The electronegativity of oxygen is more than that of hydrogen, right? The electronegativity of oxygen is more than that of hydrogen. So oxygen carries, so oxygen atom carries partial what negative charge, and hydrogen atom carries a partial positive charge. Hydrogen atom carries partial positive charge, and thus you can get the dipole moment. Understand? Why? Because there is a difference in the electronegativity. So here we can say, let us suppose here oxygen, here hydrogen, partial negative charge, this is partial positive, and all the electrons are attracted towards the oxygen atom, right? So all this about the water molecules. In linear molecules like a beryllium fluoride, in linear molecules like beryllium fluoride, we can say that the polarity of the same magnitude exists. The polarity of same magnitude exists, right? Means on the opposite side, right? Between the beryllium and the fluorine atom, between the beryllium and each fluorine atom, and that's why the dipole moment will be 0. Understand? So in the fluorine atom, but in the opposite direction, and as it is in the opposite direction, we can say that the dipole moment will be 0. Just like, see, here beryllium is there, here fluorine, and here also fluorine, right? So here there is a covalent bond, but here it will be go over here, it will be go over here, right? This carries a partial negative, this is a negative, and this is a positive, but these both are in the opposite direction. So that's why we can say that the dipole moment will be 0. So these things we have to know. As a result, the polarity becomes 0. As a result, the polarity becomes 0. Thus, the dipole moment is 0. Understand? Write down all these things. This is all about the polarity of bond, right? See here, once again, let's explain you. Polarity of bond, any chemical bond, neither it is completely covalent nor it will be completely ionic. There is some, if the covalent bond is there is some ionic properties will be there. See here, it is found. But whenever you are going to experiment the value of bond length and bond enthalpy, it will be studied that it is found some contribution of ionic bond is there, right? Heteronuclear diatomic molecules is there, in which heteronuclear means what? Hydrogen and fluorine, that is a heteronuclear, right? Homonuclear means same nucleus, H2, Cl2, all these things. Ionic bond is there from covalent bond, direct more towards the fluorine atom. Why? Because the electronegativity of fluorine will be more. जिसकी electronegativity ज़्यादा है, उसकी तरफ electron भागेगा, right? So the density of the electron in the fluorine atom will be more. So it carries a partial negative and this carries a partial positive charge, right? And thus, due to this, we can say that you can get the dipole moment. Understand? You can get the dipole moment of hydrogen fluoride. Same way, water molecules, difference is there, right? Same way here, beryllium fluoride also, right? So these are the examples of polarity of bond. Write down. Next question, let us see. Let us see. Next one, there is the right reason. Dipole moment of NH3 is more than NF3. Explain. चलो ये एक्सप्लेन करो कि डाइपोल मोमेंट Na3 की ज्यादा है क्यों NF3 से। यहाँ पे फ्लोरीन की इलेक्ट्रोनेगेटिविटी का ज्यादा है, फिर भी हम ऐसे बोलते हैं कि डाइपोल मोमेंट विल बी लेस, तो व्हाई? So let us see. First of all, I can say that the value of dipole moment of ammonia is not zero. The value of dipole moment of NH3 is not zero. Why? So it is not a linear. So it is not a linear, but it will be, the structure of molecules is pyramidal, but the structure of molecules is what? Pyramidal. Understand? So first point you have to know. Now here the electronegativity of fluorine element is more than that of hydrogen element which are present in the NH3. Like write down the electronegativity of fluorine element is more than that of electronegativity of hydrogen, more than that of hydrogen, right? The value of dipole moment of NH3 molecules is more, and here thus, but the value of dipole moment of NH3 molecules is more than that of NH3 molecules is more than that of NF3, right? In both these molecules, one non-bonding electron pair is on the central atom. In both these molecules, one non-bonding electron pair, right? One non-bonding electron pair is on central nitrogen atom. Is on central nitrogen atom, right? Now, in NH3, the polarity of all the three in NH3, the polarity of all the three N dash H bond is, the polarity of all bond is towards nitrogen atom, is towards nitrogen atom, right? So we can say that the polarity of three bond is concentrated on central nitrogen atom, so the resultant dipole moment is in this. Thus the resultant dipole moment is increased, right? Is it clear? Whereas why in NF3 we can say the polarity of NSF1 is towards fluorine atom. The polarity of what? Fluorine atom, right? Is towards the fluorine atom. Okay. Thus NF3 in NF3 N dash F1 is different direction. In thus N dash F1 is in different direction, right? So it will be divided in the three different direction. So the resultant dipole moment is less. Thus the resultant dipole moment is less in NF3. But see, if I write here NS3 and 1, 2 and 3 is a non-bonding electron pair, H, H and H. And here if I write NF3, 1, 2 and 3 is a non-bonding electron pair, F, F and F. Now what happens? See, this electronegativity is more, so all the hydrogen will be attracted towards the nitrogen atom. So here on the nitrogen atom the electron will be increased, right? Is it clear? Whereas here, which one electronegativity is more? Fluorine. So electron will be what? It will be distributed in the three different direction. फ्लोरीन के ऊपर इलेक्ट्रॉन जाएगा. यहाँ पे ये तीनों हाइड्रोजन किसको इलेक्ट्रॉन डोनेट करते हैं? नाइट्रोजन. तो नाइट्रोजन के ऊपर इलेक्ट्रॉन की डेंसिटी ज्यादा होगी, तो इट इज अ मोर इलेक्ट्रोनेगेटिव, एंड एज इट इज अ मोर इलेक्ट्रोनेगेटिव वी कैन से दैट द डाइपोल मोमेंट विल बी इंक्रीज, राइट? सो दैट्स व्हाई वी कैन से दैट हियर this NS3 is here in NS3, even if the fluorine is more electronegativity than that of hydrogen, then also NS3, the dipole moment of NS3 will be more as compared to that of NF3. Understand? So this is how you have to write down. चलो देख लो. Now last point, that is the shape and types of the molecule. Let us see. See here. Here we have given types of molecules. Types of molecules. Then after it comes example, dipole moment, example. Then dipole moment and geometrical shape, right? Okay, now let us see. First of all, type AB molecules, right? Like molecules. So यहाँ पे कौन कौन सा आएंगे? HF, HCl, HBr, HI and last one H2, right? यहाँ पे see dipole moment 1.78, 1.07, 0.96, somewhat it will be 79, 0.38 and it will be 0. All the geometrical shape it will be linear. क्या है? Linear, right? So these things you have to know. Then molecules AB2, H2O, H2S, H2O, H2S and CO2, right? Okay. Now here H2O 1.85, 0.95 and here it will be 0. What is the shape? These two will be bent. This is also bent. And CO2 it will be linear. And that's why you can say that the dipole moment will be 0. Right? Now molecules. AB3, NS3, NF3, BF3. NS3, NF3 and BF3. Right? And here, I can write down here, the dipole moment will be very high in the NS3 that we have studied, 1.47, 0.23 and this will be 0, right? So here NH3 it will be trigonal pyramidal. Trigonal pyramidal. Here also trigonal pyramidal. And last one that we can say is a planar triangle. Planar triangle. Next one, it gives what? Molecules AB4. Here it gives CH4, CHCl3 and CCl4, right? This will be 0. Here 1.04 and here it will be 0. And the shape, that is a tetrahedral. Tetrahedral. Okay, so this is how you have to remember the shape as well as the dipole moment of the different compound. Understand? AB2, AB2, AB3 and AB4 molecules, right? So today we have discussed the different points. First one, that is the polarity of bond. Then we have also explained that why the dipole moment of NF3 is less than that of NH3, right? And last one that we have discussed the geometrical shape as well as the dipole moment of the different molecules. Okay, so in this video up to here it's enough. In the next video we are going to discuss about the valence band theory. So up to here it's enough. Thank you very much.